To great jubilation, NASA's Space Launch System performed a spectacularly successful first test flight beginning November 16, 2022. Almost a month later, after multiple distant orbits of Earth's moon, the Orion capsule returned December 11th to a safe splashdown and recovery. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. Does a successful first flight finally mean that SLS will return astronauts to Earth's moon more than 50 years after astronauts last visited? Does it earn SLS a future among the United States fleet of launch vehicles? Spoiler, the answer to both questions is probably yes, which has profound consequences for the future of United States spaceflight. SLS is a Saturn V class rocket designed to return humanity to Earth's moon with a launch architecture that includes minimal assembly or refueling in orbit. It studiously avoids all the experience and lessons learned building, refueling, and maintaining the International Space Station in orbit. Called Artemis and loosely modeled on the 1960s Apollo project that beat the then Soviet Union to the lunar surface, the architecture uses space shuttle hardware and personnel to the degree possible. A second test with astronauts, Artemis II, is now planned for no sooner than 2024. Based on the program's history to date, no one should expect that date to be achieved. The successful Artemis I test followed persistent reliability problems that delayed the first flight for months. Operational delays, largely driven by severe limitations in the heritage hardware SLS is assembled from, further delayed the flight by reducing launch windows and time on the pad. All that was after an extraordinarily troubled development history, despite the project being designed around existing technology and components. A SpaceX Falcon Heavy can lift 2/3 of an SLS payload for a fraction of the cost. Credit SpaceX photo via Flickr. That history should not obscure two key facts. When SLS finally flew, it performed very well. For now, and in the immediate future, no other nation could pull off a cislunar mission with human-related hardware like Artemis I. With Artemis I safely put to bed, NASA can seriously plan for the first U.S. astronauts to visit Earth's moon since Apollo 17 in 1972, but not anytime soon. The Artemis III mission to the lunar surface depends on a variant of SpaceX's Starship launch vehicle adapted for landing. As of this writing, Starship has yet to fly even to orbit. A first orbital attempt may be imminent, but even so, 2025 is currently the earliest opportunity for Artemis III, and 2027 or beyond is more likely. NASA was forced to choose Starship as Artemis' first landing vehicle when Congress refused enough money to develop more than one design, and, unlike the other bidders, SpaceX said it would cover a significant part of the cost. Blue Origin did offer money, but only after losing to SpaceX. Since then, NASA has requested bids for additional landers. Understandably, Artemis I has led to a great deal of excitement within the space community. Nonetheless, it is worth asking, should this project continue even if it eventually performs part of a successful landing? The $4 billion plus annual cost to maintain SLS, the Orion capsule, and their infrastructure is unlikely to decline much when the rocket becomes operational. That infrastructure is capable of 2 to 3 launches per year, though expect far fewer at first. Early versions are not greatly more powerful than existing rockets, in spite of estimated costs per flight on the order of $700 million to $4 billion or more, depending on how much infrastructure and development cost is included. The Block 1 SLS can lift 95,000 kilograms to low Earth orbit, LEO, while the future Block 2 is planned to lift 130,000 kilograms into the same orbit. Comparable figures for the Delta IV Heavy and Falcon Heavy are just under 26,000 kilograms and over 63,000 kilograms, respectively. Falcon Heavy costs well under $200 million per launch, a price that includes the amortized costs of development and infrastructure. While the exact figure cannot effectively be calculated, the likely cost per kilogram of payload delivered to orbit by SLS is literally astronomical compared to what is available on the commercial market. Advocates talk of finding other markets for the SLS. However, SLS currently has no market outside of NASA, and at those prices, it is unlikely to. NASA's deputy administrator under President Obama, Lori Garver, fought SLS development as an unaffordable distraction from commercial cargo and crew, where she felt the future lies. She reports in her book Escaping Gravity that she asked the Defense Department and the intelligence agencies whether they needed or wanted SLS. She was unequivocally told no. Even within NASA, payloads that were not explicitly designed to require the SLS, or not politically required to use the rocket, are avoiding the program. This includes the Gateway Orbital Space Station in lunar orbit and even the Moon Lander, relegating SLS to launching crew into lunar orbit. That is a job any number of far cheaper rockets could handle if Orion were launched separately from the upper stage and fuel, and then docked in orbit. A similar procedure was demonstrated as early as Apollo when the command and service modules unlocked from the Saturn V's SIVB stage, rotated 180 degrees, docked with the Lunar Excursion Module, and pulled it away from the spent upper stage. All this was done deep in translunar space no less, after leaving Earth orbit. Credit, Space News Midjourney illustration. Even if the first few SLS flights proceed without a hitch, supporters are likely to be disappointed unless the program can reduce prices enough to attract non-NASA customers. Congress is unlikely to go along with greatly reducing the workforce. The program is increasing its long-term costs by building additional ground infrastructure that will need to be maintained. As NASA sees it, the agency is focused on laying out SLS's transition from design and development into a continuously operated system intended to endure until 2050 and beyond. What could the United States do with the $3 billion to $4 billion SLS and Orion will continue to consume for 2 to 3 flights per year at best? Put in financial terms, what are the lost opportunity costs of continuing to fund SLS? As a start, NASA could fly 2/3 of an SLS payload on a Falcon Heavy for well under $200 million and do it with a regular and frequent tempo. Even if an SLS flight costs just $700 million, NASA could launch 3 Falcon Heavies and lift more than twice as much as a single SLS. I've grossly underestimated the probable real cost of an SLS launch and overestimated the cost of a Falcon Heavy to be as generous as possible to SLS. A middle path. There are other medium-class rockets under development and operation at no cost to NASA that could handle lunar missions. In a distributed architecture, modular payloads would be launched to orbit and later assembled into finished spacecraft of any size and mass, where they could be fueled and supplied using techniques demonstrated building and maintaining the International Space Station. Part of the ISS was launched and assembled using Russian Proton medium-class rockets. It is fueled using freighters launched on relatively low-cost Soyuz rockets comparable to SpaceX Falcon 9s and United Launch Alliance Atlas V rockets. The ISS is supplied using Northrop Grumman Antares rockets and Falcon 9. There is no reason large lunar and planetary spacecraft cannot be built up the same way. A key advantage of a distributed architecture using multiple rockets with multiple users is that it has customers other than NASA. Fixed infrastructure costs and launch vehicle maintenance can be spread over the entire space industry. NASA does not have to pay the entire bill. What of the workforce? Most outside observers consider jobs the real reason for the SLS's otherwise inexplicably strong political support. Credit, Space News Midjourney illustration. If NASA's lunar exploration program used medium-class rockets, increased launch rates would reduce their costs through economies of scale. Frequent launches would also increase reliability. Reduced launch costs could stimulate more commercial space industries and thus larger launch businesses. More directly, money and engineers freed from SLS development and operations could be deployed to design and build lunar infrastructure, deep space exploration vehicles, and new technology high-energy propulsion. These are things NASA cannot afford to invest in while SLS consumes about 1/3 of NASA's human spaceflight budget.